So I'm a vice president working for Broadridge Financial Solutions. I've been with the organization for the past 18 years. That's about me. And I'm more passionate on the digital transformation side, where when you say digital transformation, it connects to the business and a lot of technologies as well. Okay, then with this, I'll proceed to the next thing. So what I'm going to talk today, I really want to set the context. I really don't want to bore you with a lot of technology theory and everything, but I'm going to have some slides, technology with fun. That's what I'm going to do. But this is my, I can say, quote, what I'm going to speak about. Today's topic is how we can do the AI and the real-time analytics, considering the platform engineering, how platform engineering makes a huge difference to really perform the AI and real-time analytics, considering a lot of non-functional requirements. For example, you want to say scalability, you need a performance, you need a monitoring, everything. Why these are even required? What is that AI has to do with all my architecture and hardware here? I need to go a little back, maybe around 25, 30 years back. I don't think anyone of us have heard about AI much. Agree? We all know that statisticians, professors, they used to build a lot of algorithms, and they used to write, nice, prediction models and everything. With the advancements in hardware and platforms and software, a lot of architectures, and AI has become so prominent today. It is like AI cannot live without you having the right architecture, hardware, and software today. And same vice versa, right? Our architectures have been changing the way they are, in making the better processing power, CPUs, and everything, considering AI in view. So they're tightly coupled. So my thought process today is to explain that AI and what we do as part of our application development, whatever the architectures we consider, whatever the hardware we consider, they are not separate anymore. Anyone can leverage AI. It's not that AI is only for some people. AI is for everyone, and we all can adopt AI. It's not that you have to write greatest algorithms to know AI today. Okay, that's what I'm going to teach, give some, take certain small examples, how we can, because I cannot cover all the AI, I have just taken how to do the real-time AI analytics using all these, your platform, and how the engineering excellence we can achieve, while we want to implement something through AI. Okay, thank you. Any questions before I proceed? Okay, this is what I'm going to introduce. Now we know that everything is data-driven decision today. Someone makes a credit card transaction. How can you know that the transaction is fraud or not? In the real time. It has to know the pattern, the way the transaction has happened today. It has to get into the previous patterns, historical, and your AI model has to work. Imagine millions of transactions happening in an hour. And can AI perform unless you have the right platform for you here? It's impossible to do it. Am I correct? That's very important. And that's what I mentioned here. I can probably skip this. And pretty much this is what we are going to talk today. And you have real-time AI analytics here. I want to do a real-time AI analytics. What exactly? Let's take the simple example of the fraud detection. It could be anything. I'm just taking that. And for that, you need a platform. You need event-driven programming, which most of you might be aware, right? If you know microservices and a lot of other things today. So what is event-driven programming? You're getting the data in the real time, probably, and some event will be triggered. You may be using Kafka kind of technologies and something, and you need a performance also, where you have to consider all the non-functional requirements like performance, monitoring, scalability. Why these are needed for AI? They are needed because when you are having millions of transactions coming in an hour, your system should have the ability to apply your AI model. Even your AI model also should be scalable at the same time. Without that, you cannot do it. So most of you might be, it is a common question that comes to me. Many technologists come and ask me, hey, I want to become a data scientist. and I want to change my career from technology, our enterprise architecture to AI, I first ask them why you want to do it. Because it's paying more money? Is that the reason? Then you really need to think, actually. Because AI is not only for people who only use AI, I mean to say, who write the AI algorithms. AI is for everyone. In your Java application, your .NET application, you can definitely use AI if you really understand this platform architecture and the non-functional requirements and build your system towards this. Okay? Just a funny slide. I just created again AI-based slide. I have not done this. Okay, see, all my slides today, whatever I'm showing, I purposely took the decision that I don't want to create anything on my own. Let AI generate for me. I purposely did it. What is it saying? Oh, you have AI observing, and you have to do the real-time AI analytics, like I said, the fraud detection, and for this you need the build the system like non-functional requirements, security, scalability, reliability, observability, and you need the orchestration like Kubernetes, Docker, and everything to do AI. Okay, this is what this holds. And cloud is, of course, you know what cloud does, where you can outdo the scaling and a lot of infrastructure, pay-per-use, a lot of other things. Okay, I definitely ensure next 5-10 minutes is going to be fun. Okay. Imagine a situation where I want to have a AI coffee maker. What is AI coffee maker? A coffee maker which senses you and tries to detect what are your preferences. The moment you enter the coffee room, or it may scan you, whatever that ID, or it may somehow senses you, and it has to know what kind of coffee you might like based on your historical preferences. Can you imagine that? I know it could be imagined, but we can make it happen also, right? So it understands you. Oh, probably Sarath liked it. My name is Sarath. So Sarath liked espresso. Probably he always takes espresso, for example. Let him have espresso. Let me brew espresso for him. And also, he has a limitation what kind of brewing he likes to have. What time the coffee has to be brewed up to, okay? Or it can also be that it may say, I have a long meeting. It knows that the moment I enter into the coffee room, whatever the AI coffee machine is there, it knows that what are my meetings, for example. Imagine this. Maybe we are going to be there very soon. Okay, I'm just taking it for ease of explanation. It knows that I am going to have a long meeting for next 2 hours and says that, oh, you need a strong double coffee because last time when you had a long meeting, you have taken the same thing. And it starts preparing, and it will also improvise itself the taste. It tries to optimize the taste based on our feedback and everything. Can you imagine? And it's a fun, I'm just explaining it fun. But how can I have such an AI coffee machine where there's a lot of fun involved, where it understands my preferences and automatically acts accordingly? How can I really implement it? What is that I need to know from the technology perspective? Okay, that's exactly I'm going to talk today. A simple conversation. Few engineers like us are there. Did you hear about so a person X asks, for example, engineer asks there, right? Did you hear about AI-driven coffee system? It's supposed to know exactly how we like our coffee. Then the other guy says, oh, you mean the smart barista? I heard it got AI that monitors the caffeine habits, and is just is making some fun that probably the next bean therapy is required. What it means is, if AIs are getting overloaded, they need some therapy. Okay, what it means is, they also need the right scalability. They cannot heat up today, right? That's very important to understand. Why it's very important, you're all working in the generative AI world today. I hope you know that if you make a generative AI query today, one query in chart using your chart GPT, whatever it is, I heard that it takes some 2 liters of water to reduce the heat. That's how the servers are heating up today. And recently, the OpenAI CEO mentioned a statement, hey, please don't use please and sorry when you're making a query. It is, we are ending up in a lot of, we are in need of a lot of processing capability. Our systems are getting heated up a lot and again. Imagine, despite we are having a lot of infrastructure today, still we're having the challenges of, to make the AI successful. So what I'm trying to cover here is, in your enterprise applications, whenever you are going to, whatever you're building, when your manager comes and asks you to implement some AI, like the fraud detection, real-time analytics, it is very important to consider that how your systems are scalable today, how your systems can perform today. Now, what kind of monitoring you have? Or do you have a Datadog kind of a monitoring mechanisms? Do you have some alert mechanisms there? It is very important to consider all these architectural things here. I'll come to this. Then after this, he said that there is a AI mission, and it uses machine learning to learn our brew preferences, because you can have it learn, right? You can train the model and keep the model ready, and if you want, you can have the self correction also. It can keep on training itself on its own as it goes. And then it just says, the system uses real-time analytics to predict your need for caffeine, processing recent patterns like what were your meetings and other previous history actually. Here I didn't cover technology, but I just said you collect the data, analyze the patterns, predict the needs, optimize the brew, and serve the coffee. But now we'll come to the technical aspects of it. How do I implement this? Same conversation. Detect the presence. Oh, I'm there, I'm near the coffee machine. Let it detect the presence. Trigger microservices. What is a microservice? What is that microservice is going to do in a coffee machine? Imagine you have multiple coffee options like espresso, cappuccino, whatever are available today. And there is a more demand for cappuccino, for example. And you can build that cappuccino microservice, which you can scale independently. Correct? So so when it detects the presence, based on my preferences, it will trigger the respective microservice. Probably cappuccino is what I prefer. That will trigger that, and it brews the coffee and scale the resources depending on if it sees that there are less number of microservices available. Probably it has to spin off more Docker instances of the microservice and use Kubernetes for orchestration purposes. Okay, just imagine this. I'm just taking the coffee because just to simplify our thought process, but it's a need here, right? So now we have spoken about one thing. What is that? Detected presence. So an event-driven programming. You may have a Kafka here which receives a message, and the event triggers, and that triggers our microservice. So you have a Kafka which is a scalable environment, and you also have your AI model, where it could be simple Python API or Java. I'm not talking about the technology here, but your AI model runs in this microservice. Okay, that you need to scale it accordingly. Non-functional requirements, why these are also important? Let me give an example of this. Now, another engineer is concerned, hey, it's going to know that, whenever, how many times I'm having my coffee, and the system dashboard is going to show it up. And what if my HR comes to know that I'm only spending my time taking coffee all the time, correct? So now it says, yes, what is important here is your encryption. I am protecting everything. For example, if you are using AWS, probably Azure may have some other different thing. It's very important to consider the security aspects of it. Okay, when you are building your AI system, security is very important. And the observability. Why observability and monitoring is important? Observability is important because it will keep on looking, it will keep on reading all the preferences that the user or whoever is consuming that coffee, that needs to be logged in, so that it will understand what is that people are liking the most, right? So that observability is required, and also it has to be monitored. What if something? Imagine a case where the milk powder is over or coffee powder is over. It has to monitor that, immediately send an alert there. Okay, so that's all this a simple coffee example. I'm just trying to make it simple for you so that instead of writing big architectures, these are the whole AI coffee maker overview for you. Learn the preferences, optimize the brew times, manage the orders, and scale the resources, track consumption, alert for supplies, refine the test is very important. It has to optimize on its own, correct? And then it's a cycles here actually. Just in the interest of another 5 minutes, I'll spend another simple example, very imaginative. I need a plant bought 3,000. What does it mean actually? I want to check the plant health status, whether the leaves are coming up properly or not. Is there anything that does it require more sunlight? or does it need to be put into some dark? Does it need more water? Is water is more required, or is it because of the leaf is not growing because sun is less? Imaginative, but it is going to happen very soon, right? In these cases, how can I build that real-time, how real-time AI analytics are going to help me here? Now, same, another set of engineers are discussing about this. Hey, have you heard of the new AI-driven office plant care system? It is supposedly green thumb certified. Okay, they're just having a conversation here. And it says, yes, I heard of it. And it do offer therapy sessions for wilting leaves. Means, what it means is, it's going to say a leaf is not growing properly, it is going to immediately alert. Alert me. That's the event-driven programming I'm talking about. And then, that's where the real-time analytics coming. Yeah, that's what they're discussing, right? Continuously, so each decision on the freshness leaf data is available. So what is the status of the leaf? Is it not in the green or is not growing properly? Anything? That is one thing. And it calculates exactly how much water each plant needs, accounting for recent changes in weather patterns or if someone left the window open. It's all a funny conversation, it appears, but look at the technology aspects of it, how event-driven programming is helping here. Now look at this. The next day, they started thinking about what kind of architectural patterns are needed, what are the engineering practices I need to be focused on. Let me look at this. This is a very interesting slide you may see. When driven architecture, it has to understand the triggers are going to be your soil dryness, light, dimness, and mist playlist. Mist playlist, why I'm saying, because I'll come to that. Plants listen to music. Right? Their growth will differ based on the music also. That's a different science. I'm not going there, that part. But I'm just giving an example. Because if it's not growing, is it because it is responding positively, and how my event-driven program will help? And there's scalability aspects of it, which we can achieve through containerization and Kubernetes here. And again, tailored responses like watering, binds adjustment, and then microservices, plant-specific needs. Each plant has a different thing. So for each plant, you can probably build a microservice there. So this is all the discussion. I'll just, in the interest of time, I will skip this. But at the end, what they're trying to do here is, they're trying to have the real-time analytics dashboard. Again, there is a concern here. What if my plant knows that your rubber plant might prefer jaws or rock? There's a security aspect there. They don't want to even reveal that aspect because it's security. So I need an IAM and all the security that is required here. And if the plant is stressed out next to our office coffee machine, plant bot might probably trigger an event. You have a coffee machine next to the plant, and the sound is making it troublesome, and then you need a triggering mechanism here. So what I'm trying to cover with those two examples, funny examples, is AI is not, you cannot achieve anything with AI independently, unless you can use it in your platforms, unless you really apply it at your work. Okay, that is it. That is a message I just want to share with you all. So anyone can learn AI today. Anyone can adopt AI today. Okay. Now, this is the whole thing, which I will skip in the interest of time. And now, this is what exactly how we can achieve the engineering excellence in real-time analytics. What is important here is your data ingestion here. Data is coming in the real time, and then you have the anomaly detection, like it could be fraud or it could be any event. It need not be anything, right? And then you also need the scalability management very much, how you can scale dynamically. And then you need the data management, of course. You may need to use your vector databases, right? You know vector database if you know AI a little bit. And then you also need the observability and security. Please go by these important things whenever you're trying to implement AI. Doing AI separately for some experimentation is different, but applying the AI in the real time, and especially to make it to productionize it, is very, very, you need to understand the technology. So technology is not going away. We're all confused. Today I understand that AI, but AI cannot survive unless you know if you're a technologist, we all need to be aware of the enterprise applications, architectures, whatever I have spoken so far. Small example, nothing but we have already covered this, but I'm just going to reiterate that. I want to do the same fraud detection which I have given the example in the beginning of the session, where if a transaction happens, how do I know that the transaction is fraud or not? So how I can build my system with all considering all my enterprise architecture, patterns, platform engineering, everything together here. Now I have the data ingestion happening. I may use some Kafka, for example. When the data is getting ingested, I may use Kafka kind of things, and then do the pre-processing, because I need to clean some data. Even for pre-processing also, I should be in a position to scale my pre-processing logic. Because what if millions of transactions are there? I need to clean each and every record. Because remember, this is real time. This is not batch, right? So I should be able to have more and more instances running so that they can scale easily. You can using some Lambda or anything, wherever you want to write your logic. And then you have the anomaly detection, which is very critical, because that's where actually your AI model, it could be auto-encoder or anything, whatever you prefer to use, can be used here. So if you're using some TensorFlow as a framework, for example, and probably you have to implement your own, call the required algorithm, Python algorithm, whatever is required, and then you need to do the orchestration, decision making. Why orchestration is important? Because you should be able to spin off more instances. You must have an ability to orchestrate them so that when to have more instances, when to reduce the instances, all kind of orchestration is required. And then you will have the data storage like vector database. You all know vector database does all the encoding, decoding, so right? And then you'll have the key thing is observability and lifecycle management. Just for a small one fraud detection example, these are the considerations one must be having it. Okay, so whoever is say I know Docker, I know microservices, they may be thinking, hey, how can I go into AI? It's a big question. Oh, do I need to know a lot of algorithms? Do I need to be an expert in statistics? Not required. In this forum, I'm saying this. Okay, you don't need to master everything, but you need to be aware of what are they, but how you can implement day-to-day work. This is a quick sequence diagram. It's not something new I'm showing, but you have the transaction data, and then you're doing streaming the data for processing using Kafka, and then you have detecting the anomalies, and then you're storing the process data in the vector database, and then probably you can do the scaling, if at all a scaling is required here, and then manage the workloads, and just like querying the pattern recognition, because you need to know whether the data that is coming in is fraud or not, and then provide the fraud detection results, and all the observability log and everything will come in picture. It's just a sequence diagram for just explaining it better. Same thing, I'll skip it. I just made it because I just wanted to show that how deployment orchestrations are one set and processing and detection are another flow actually, which can go independently. But this is a whole thing. There's a summary of everything that we have discussed just now. Data ingestion layer. So you may get data from online payment gateways, point of sales terminals, mobile apps. Your Kafka might be processing them in the event-driven programming. Then you may apply your auto-processing anomaly detection, which might be spin-off based on the Docker. And then you will have the actual detection, your tensor model, whatever you're using, whether you use. I'll come to the AWS and other things later part. Then you have all the CloudWatch if you're using AWS. Because I worked on AWS, I'm speaking about AWS, but I'm not biased with that cloud vendor. And you have the centralized logging and all other stuff. And then, of course, you have at the end, which is a separate thing, the deployment orchestration done by Docker and Kubernetes there. So if you prefer, no, I don't have time to use TensorFlow or anything. Probably if you are considering AWS, for example, you have SageMaker, where you can use to train your model and then continue to use it, where it will automatically take care of the architecture needs like orchestration, Docker, and everything here. And that's how you can use it. And if you are, no, I don't want to go with our regular AI model, but rather I would prefer to go with a generative AI, then you can go with AWS Bedrock, because as long as if you're very good at the pattern, what is that? We do, if you're prompt engineering, if you're very good at prompt engineering, you know how to use it effectively, then you can go with the AWS Bedrock, depending on your business needs actually. So what is the future trend? What is going to happen with the AI? The next thing is going to be self-optimizing systems, where they automatically learn from what they have been seeing in the real time, okay? And then they will automatically try to learn it. And then you will also have autonomous decision making, where systems will take a decision, what is the next thing to do? So like, you all might have heard of AI agents, right? Which automatically take their decisions. And then you have the edge and hybrid architectures. So it is very important that where data resides, your AI model should go into the data and apply. Not the data has to come to the AI. Okay, that's one important thing. With that, I will conclude it. The same thing which I mentioned here. So have the best practices, ensure that architectures and everything is considered. Okay, and I'm sure that with this, you all can use AI in your day-to-day works. So that is the only thing I would like to share with you all. AI is not tough for any application developer. You all can embrace it with an immediate effect. You just need to be aware of it, what it does. Okay, that's all. I just want to conclude the session. Thank you.